Hi guys, so today we're going to continue working on topic 17. We're going to continue working with probability and more specifically with compound probability. So to get things started, we're going to talk first about a compound event. A compound event is just an event when there is more than one possible outcome. So this involves multi-step actions, and determining the probability involves finding the sum of the probabilities of the individual events. So just to remind you, to find probability of an event, just in general finding probability or theoretical probability, we are going to look at the number of favorable outcomes over the number of possible outcomes. Okay. When we are looking at our compound events, one way that we can find compound probability is to use an area model. This way is really good for when you have two different actions that we're looking at. So when we want to use an area model, the first thing we want to do is list all possible outcomes for each action to create a table. So we're going to fill in outcomes here. Okay, so to do that, one action goes across the top as your columns label. And one action, the other action goes across the side as your rows label. So you're basically going to set up a table, and we're going to fill those in. We'll fill in the remainder of the table with the combination of letters and or numbers to show outcomes. We find the probability. To do that, we find the numerator, the number on top, by counting up all the desired or the favorable outcomes. Those are the ones we're looking at, the ones we're looking for. And then to find the denominator, we are going to count up all the possible outcomes. And those are all the boxes. So how many total boxes we have within our table. So let's take a look at some examples. We'll work through these together and we will use our area model. All right, so it says here in a bag with 5 marbles, 2 are red and 3 are blue. What is the probability of choosing 2 red marbles if you replace the marble each time? Okay, so we have our first choice here, right? So our first choice could be red, red, blue, blue, or blue. And then our second choice could be blue, 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 red, or red. Okay, so we've got all those covered. And we want to know what our probability is here of choosing 2 red. So let's look at what we know. If we count up the number of boxes in here, that's going to tell us our total outcomes, our total boxes. So we have 25 total boxes. And our boxes, remember, are our outcomes. So we want to look at how many of those have 2 reds, okay? And that's this highlighted section down here. We have 4 different outcomes from this probability model that are both red. So 4 outcomes with 2 reds. So we're going to combine these two to write our probability. So our favorable outcomes, what we're looking for, that's 4 out of our total, which is 25. So our probability of getting 2 red would be 4/25. All right, so this time we're going to create our own model. And we are going to look more specifically at rolling a 4 on a normal 6-sided die and flipping heads on a coin. So I want to first start by setting up my table. So again, we want to have 1 outcome on our side, 1 going across the top. So the action I'm going to look at first up here is dice, right? So we're going to list this up here on the top, and I'm just going to kind of draw some arrows to show where we're going to go across. So I'm going to list my outcomes, which is 1, 2, 3, 4, 5, and 6. And I'm just going to start setting up my table. So I'm going to just draw some lines. And then I also have my action of flipping my coin. And those outcomes are going to be either heads or tails. So I'm going to put heads here, tails down here, and I'm going to separate these. All right, so over here, I'm going to try and fill this in and right. So these are for my coin. Okay, so now I'm just going to fill in my table. So if I were to flip heads, I have the options of getting heads and 1, heads and a 2, heads and 3, heads and a 4, heads and 5, and heads and 6. If I flip tails, my outcomes could be tails 1, tails 2, tails 3, tails 4, tails 5, or tails 6. So I want to look at the probability of rolling a 4 and flipping heads. So I'm looking for this one right here. This is one outcome where I have heads and 4. And that is my one favorable outcome out of my total. So I'm going to come back here and count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1/12 would be the probability of rolling a 4 and flipping a heads. Okay, so let's go ahead and take a look at our next example here. All right, the table shows the results of spinning the wheel once and tossing a coin 41 times. Find the theoretical and experimental probabilities of spinning a 1 and tossing a tails. So if we come over here, so we've got our spinner here, 1, 2, and 3, and we have a list written out for all of our different outcomes. So we could get a 1 and a heads, a 1 and a tails, 2 and a heads, 2 tails, 3 heads, 3 tails. Those are all of our different outcomes. So if we're looking for the theoretical probability, again, of spinning a 1 and tossing a tails, that is this one right here. So there's one outcome of spinning a 1 and getting a tails. So that is going to be 1. My favorable outcome is 1 out of a total of 1, 2, 3, 4, 5, 6. So my theoretical probability is going to be 1/6. So this first part over here is talking about the theoretical. Now, this part over here is talking about our experimental probability. And if we look, these are all of our different outcomes. And if we add these together, if I look at all of those and I add them, they equal up to 41 because we did 41 trials. So for the experimental probability of getting a 1 and a tails, I look over here at my event and they tell me that occurred 8 times out of 41. So my experimental probability would be 8 out of 41 because that occurred 8 times out of my 41 trials. Okay, so let's go ahead and take a look at the back. On the back, we're going to start using some tree diagrams. And we introduced these yesterday in the notes, but we're going to really break this down and do a little bit more with them. So when we use a tree diagram, the first thing we want to do is choose one of your actions to start with. Once we've chosen our action, we're going to list all the possible outcomes of that action. So these will be the first set of branches in your tree diagram. Okay. The second thing we will do is focus on your second action. So we're going to look at the second action and we're going to list all of those possible outcomes of that action, and those are going to be your branches under each of our original branches. So we're going to start with our first outcome and then it's going to branch off to our second outcomes. We're going to continue that process until you've completed all actions. Then to find the probability, to find our numerator, we're going to count up all of our favorable outcomes again. Those are the ones we're looking for. And to find the denominator, we're going to count up all the possible outcomes. So we will put our favorable outcomes over our possible outcomes again. So these are all the lower branches. All right, so we're going to do, I know this sounds a little confusing, so it's going to make a lot more sense when you see it in action and see how to do it. So let's take a look at these examples. It says find the probability of tossing tails twice and heads once. Okay, so they already set up the tree diagram for us. So what we're looking at first, our first two branches here is our first action, and that is our first coin toss. So of that first action, our outcomes are either heads or tails. From there, we want to toss the coin again. That's going to be our second action. So if I were to get a heads the first time, my possible outcomes are either heads or tails. The same for if I would have flipped a tails the first time. It would be either heads or tails. So then if I want to do a third toss, I'm going to branch off of each of these, and it could again be heads or tails, heads or tails, heads or tails, heads or tails. So in order to list my outcomes, I just follow my tree. So I would go heads, 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 and that's my outcome here. Heads, heads, tails, heads, tails, heads. So you can see where all these outcomes are coming from. So if I want to know the probability of getting tails 2 times and heads once, I'm just going to come down all my outcomes and look for 2 tails and 1 heads. I have 1 here, I have 1 here, and 1 here. So that means I have 3 favorable outcomes, 3 outcomes of what I'm looking for, my 2 tails and 1 heads. Out of my total possible, I just count up my total outcomes. So I have 1, 2, 3, 4, 5, 6, 7, 8. So my probability of getting 2 tails and 1 heads is 3/8. All right, so then our next problem, we are going to create our own tree diagram. So we want to find the probability of choosing a red marble out of a bag that has red, blue, and yellow, and rolling a 2 on a normal 6-sided die. So my first action is going to be to pick out a marble. And remember, I've got 3 choices here. So I'm going to start with my 3 marble choices, and that's going to be red, blue, or yellow. Now, off of that, those are my marble choices. My next event is going to be to roll a die, and I want to know how many, or I want to know the probability of getting a 2. So what I'm going to do is for each of these, I have to list out all my possible outcomes for rolling a die, and I'm going to squeeze these in because this is going to be kind of tight. So for my red, I could get 1, 2, 3, 4, 5, or 6, and the same with my blue. I could get 1, 2, 3, 4, 5, or 6. And it's going to be the same with my yellow, and I'm just going to kind of bring those down here so I can squeeze them all in. But again, I have all of those possible outcomes listed. So when I look at all these outcomes, I want to look for the one that is red and a 2. So red, 2. That only shows up 1 time. So that is going to be a probability of 1 out of all my possible outcomes. So I have 6 outcomes here, another 6, and another 6. So that's going to be a total of 18 outcomes. So that is going to give me a probability of 1/18. Okay, let's take a look at our last example and work through it. All right, so it says choose the correct tree diagram below for choosing a vowel, A, E, I, O, or U, and then a number, 1 or 2. Then use the correct diagram to find the probability of choosing E and a 2. So we're first going to look for which one has the correct tree diagram. So we're saying our first action is going to be choosing a vowel. So I want to look for A, E, I, O, and U. And for A, we've got those listed first. For B, we have them listed first. For C, they list out our numbers first. So that is not what we're looking for. And for D, we list out numbers, but we also added 3 and 4, which are not even part of our action. So we're looking at A or B. So we're going to look at each of these. So in A, we have A, E, I, O, and U, but then off of each of those, we have 1, 2, and 3. We're only looking at choosing a number 1 or 2. So A is not going to work. It's actually going to be B because we have our vowels, and off of each vowel, we have 1 and 2. So B is going to be our correct tree diagram. And then I don't know why it keeps disappearing. We'll just go with B. And then we want to actually find the probability of choosing an E and a 2. So I'm going to follow my tree diagram and I'm going to find my E and my 2. So that only occurs one time. So my favorable outcomes is 1 out of, and I want to know how many total outcomes I had. So I had A1 and A2, E1 and E2. So I can count each of these up. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of choosing E and 2 is 1/10. Okay, so I hope this helps explain how we can find our compound events and our compound probability using both the area model and the tree diagrams. Obviously, if you only have two actions, setting up an area model is not difficult. We can set up our table and we can find our probabilities that way. If we have more than 2 actions, a tree diagram is going to probably be our easiest way to solve that. It just kind of helps us to see the probability a little bit easier and see all of our possible outcomes. If you have any questions about any of this, you feel free to go back, rewatch parts that you don't understand, or always ask questions. Raise your hand, ask your teacher. We're happy to help you through it. After you're done watching this video, you're going to continue on to the practice.